Hey students, well, let's start your 3.3 notes, graphing cubic functions, okay? So cubic function, as you can see right here, it has a degree of number 3. So the parent function is going to be y equals x to the third. And again, we are going to study the HK form of your cubic function. As you can see, it's very similar to your absolute value as well as your quadratic HK form. The HK for the cubic function is not the vertex anymore, but we have a new vocabulary. The HK is called the inflection point. An inflection point is a point at which a change in direction of the curvature. Okay, so when we graph it out, I will explain to you why there's a change in curvature. So similarly to the quadratic, guys, we will start with your x and y table for the cubic function. Remember, technically, you should pick values that are easy for you, but the easiest 5 values are still going to be the -2, -1, 0, 1, and 2. Now some students said, well, can I pick -10, -5, 0, 5, and 10? Yes. So whenever you guys are using points, it's always a good idea to pick some numbers that are positive and negative when possible. So -2, okay, raised to the third power is -8. -1 raised to the third power is going to be a -1. 0 raised to the third power is 0. 1 to the third power is 1. And 2 to the third is now a positive 8. So -2 students, we are going to go to -8. -1 is -1. 0 is 0. 1 is 1. And 2 is at 8. So as you can see, it's not a U shape, but more like a snake, right? Now, what do you mean by the change in curvature? So this right here is where the inflection point is. So this is curving downward a little bit, as you can see, right? So think of it as curving downward, and then all of a sudden we're curving up. So that's what they mean by a change in curvature. Okay, so inflection point breaks up the change in curvature. This is something that you should really write in your explanation of the work. So we are going to fill out the chart just like your quadratic. H comma K, since this is the parent, it's staying at 0. Your domain is going to be all real numbers. Okay, now if you like to write it as an interval notation, that is also acceptable. We do not have an axis of symmetry here. The range is also all real, okay, or -infinity to infinity. The rate of change, because it's not a straight line, students, we are going to say it varies. The entire function, guys, it's increasing, okay? So it's increasing over the entire domain of your cubic function. Since this is the parent function, the x and y intercept, they're both going to be at the same point, which is at the origin. Since the entire function is increasing, there is nothing left for decreasing because every single x value is already used. There's no min and there's no max. Because guys, there's not a highest or lowest since we have an arrow here and another arrow at the top. So that means it goes up forever and down forever. This is definitely a function, okay, so yes, and it's definitely a one-to-one because it does pass your horizontal line test. Doesn't matter what horizontal line we make, it only crosses one time. And that's how we graph the parent function. Let's refresh our memory on the transformations. If A is negative, students, we will have a vertical reflection. Now, sometimes I also call it reflection over the x-axis, okay? Or reflect over x-axis. Those languages are exactly the same thing. Now, absolute value of a is less than 1, for example. Okay, something that's less than 1 is like 1/2. 7 over 9, right? 1 over 10, ... Anything like that, this is going to be a vertical compression. And the word vertical itself is very important, okay? Factor of that value, whatever that value is, so let's call it a. Now, if a is bigger than 1, so i.e. 2.5, 7, 3, ... Okay, notice how it's its absolute value, so neither of these students is going to be negative. If it's negative, then it's already going to be a reflection. So if a is bigger than 1, this is going to be a vertical stretch factor of that value, whatever that value may be, okay? If H students, it's positive, that means we are going to translate, okay, translation to the right by H units. If H is negative, we will have a translation to the left by whatever that H unit is, okay? H units. Now, similarly to K, except now it's up and down. If K, oops, this is supposed to be a K. Okay. If K is positive, guys, okay, so positive, we can have a translation upward, okay, so up by K units. If K is negative, it's going to go down by K units. Our direction, for example, 2 states, identify the values for A, H, and K, then lists the transformations from the parent function. So students, because our HK form looks like this, okay, so that allows us to say that A is -3, H is going to be -9 because it needs to be the opposite of that to make it a +9, and then K stays at 5. Now, because we have 3 transformations here, well, 3 values here, but, okay, there's a big but right here. Since A is -3, okay, so this is technically the correct answer for A, H, and K. But when A is a -3, it's technically a -1 times 3. So that will give us 2 transformations for the A. So I'm going to make 4 bullet points here because A being a -3 will give us 2 transformations. The negative is going to be a vertical reflection. And yes, you can say reflect over the x-axis, okay? And then the 3, since that's a value that's bigger than 1, that is going to be a vertical stretch. And as you can see, I'm using V for vertical, okay? Vertical stretch factor of 3. Now, H being a -9 students, that's gonna help us move the graph to the left 9 units, okay? So left 9 units. Now, yes, you can totally add in translation to the left 9 units. And then K being +5, that's gonna move the graph up 5 units. So translate up 5 units, it's also okay to have. So these right here is what we need to box up along with the A, H, N, and K. Now, remember, we're giving you guys space over here. So if you need to write down the A value being -3, having 2 transformations, maybe that's a good idea. So when you guys are reviewing for your test, that will kind of jog your memory a bit better. All right, example 3 and 4 says, identify the A, H, and K again and find we are not doing the vertex since this is a cubic, so, and find the inflection. So can you please help me fix that? oh, it's not writing for me. There you go. Inflection point. Okay. We are not going to have an axis of symmetry. Okay. List the transformation and graph, then fill in the table. So cross that out. You're not going to have an axis of symmetry. Okay. So first, list this out. Our A is -1 because if you don't see a number and there's a negative sign, that's a -1. H equal, this is a +2, so we're going to, H is a -2. This is a -3, so K is going to keep its sign, okay? So we are going to have our X and Y for the parent, okay? Remember, your parent is always going to be Y equals X to the third. And I'm also going to make a second table here for the transform. I'll use green for the transformation table, okay? All right, let's start with the parent. We are going to use these 5 values. You don't have to, but these are the easiest. So -2 to the third, students, is -8, -1, 0, 1, and 8. No, we are not plotting those because we need to use A, H, and K and transform. So over here is a transformation table. Okay, so -1, that's going to be multiplied with all of the y's. H being -2, so whatever x we got from the parent, we will -2 since that's going to be a left. K is -3, is going to move our graph down 3. So take all of these and change those. And then we use a different highlighter. Ooh, let's use pink, that's pretty. All of that and change that, okay? So let's do, here we go. Let's do the x's first, the yellow. So -2 minus 2, students, is -4. So we just got done with this value, okay? Next, we're going to do -1. -1 minus 2 is going to be -3. 0 minus 2 is -2. 1 minus 2 is -1. And 2 minus 2 is 0. Then we are going to transform the y. Next, first value is -8. So -1 times -8, students, that's going to be a +8, okay? +8 minus 3, the first y value, let me just erase that really quickly, it's going to be 5, okay? So let me make it bigger since I'm writing much bigger over here. All right, next is going to be -1, similar math. -1 in the front times -1 minus 3. So that's going to be +1 minus 3. That's going to be a -2. Next is this 0 right here. 0 times anything is 0. 0 minus 3, students, is -3. Next value is 1. -1 times 1 minus 3. So that's a -1 minus 3 is now a -4. And then last is 8. -1 times 8 is -8. -8 minus 3 is -11. So let's plot our 5 values. -4, we are going up 5. -3 is -2, so go right there. -2 is going to be -3. -1 is -4. And 0 is -11. So go beyond this grid a little bit. It's okay to go off the grid. And remember, it's not supposed to look like a U or a V, but it looks more like a snake, right? So snake, and it goes like more like this. Okay. So A, H, and K, -1, -2, -3. So we have 3 transformations, 1 dot, 2 dots, and 3. The negative A being -1, sorry, the A being -1, it's a vertical reflection. The H being -2, we will go left 2 units. Okay. And then the K being -3, we are moving down the entire graph down 3 units. So those are the 3 transformations. Let's fill in the rest. Inflection point, it's always going to be your H and your K, so -2, -3. Your domain and students and your range for your cubic function will always be all reals. Your rate of change is not a straight line, so we are going to say it varies. Let's see. We do have an x-intercept and a y-intercept. So a y-intercept, students, when x is 0, so look, I have an x being 0 right here, so I don't need to do any work. I'm just going to fill that in, okay? But x-intercept, we do need to do a bit more work in a little bit. So this function, it looks like it's decreasing, okay? So we are going to say decreasing the entire interval of domain. That means there is nothing left for the increasing. It is definitely a function for all of your cubic functions, and it's definitely a one-to-one. Cubic function students do not have a min or max. So the only last step we need to do is going to be your x-intercept. Since we know it crosses over the x-axis, but it's not a nice value. So x-int is going to be y equals to 0. So 0 equals -1 was in the front, and then x plus 3, no, x plus 2 to the third power, and then minus 3. So step number 1, add 3 to both sides. So that's 3 equals -1 times a quantity, x plus 2 to the third. Next step, we are going to divide both sides by -1. Let me erase my line there. So now we are going to have a -3 equals x plus 2 to the third power. Then, remember, to undo power of 3, we are going to cube root both sides, okay? So it's going to look like this. So now we have, I'm going to move it over here since I'm out of space. I write way too big. So this is what it looks like. Cube root -3 equals x plus 2. I'm going to do it like this, and then I'm going to show you, okay, like that. Now, the cube root, students, and a power 3, those will cancel each other out. So on this right side, we have an x plus 2. Now, under this cube root, we have a -1 times 3, okay? Because that will make a -3. And a -1, yes, you can definitely simplify, okay, cube root of -1, because, think about this for a second, guys. -1 raised to the third power is -1. So cube root of a -1, it's just going backwards. So that means we have a -1. Cube root of 3, okay, we can't really find 3 numbers to multiply equals 3. So that's a prime number. So we're going to leave it just like that. And then the very last step, students, is minusing 2 from here. So this is a -1 times cube root of 3 is technically, you can write it like this, right? Cube root of -3 with a negative symbol in the front. That's the same thing as -1. And then you can minus 2 equals x. Now some students said, well, can I put the -2 in the front? Yes, you can. So another way to write it like this is -2 minus cube root of 3 equals x. Now remember, when you're writing an x-intercept, we have to list it as an ordered pair. So that's going to look like -2 minus, remember this index has to be small, cube root of 3, comma 0, just like that. All right, so this is your last example in here, but as you can see here, this direction is slightly different. Okay, it says there are mistakes in the graph and table shown in question number 4. Fix your mistakes here and explain what was done wrong on how you fix it. Now, I would like for you to take a few minutes and do this on your own. You will not get credit, students, if this is not done when you turn in your notes outline. Okay, so get it done and then go and check the key on your weekly agenda. Have a great day.